All right, this video is going to be on writing equations for a geometric sequence. So I'm just going to start with this sequence up here. So it goes 2 to 6 to 18 and then dot, dot, dot. So that pattern continues. So it looks like we are multiplying by 3 to get from term to term. So again, that's how I could tell initially that it's geometric as opposed to arithmetic. So to write the explicit equation, we need the same two things as we do in arithmetic. So we need the zero term, which is like the initial value, and then we also need the common ratio. So T of n equals, so to get to any term, here's what I can do. So we'll take our initial term, which is our zero term. Now, if going forward, we're multiplying by 3, okay, so this is like term 1, right? This is term 2, this is term 3. I need term 0. So again, if going forward, we're multiplying by 3, if we go backwards, I actually need to divide by 3. So 2 divided by 3, I'm actually just going to keep it as 2/3, okay? So then that times my common ratio, which is 3, and I'm multiplying by 3 consistently, so I'm going to put to the power of n. So that would be our explicit equation. And then recursive, same idea here. You need to give a starting point, all right? So you could give me that t of 0 equals 2/3, or you could give me t of 1 equals 2. So I'm going to act like we didn't do this, and I'm just looking at this original sequence up here. So I will say t of 1 equals 2. And then to get to my next term, so remember n plus 1 means the next term, okay? So if I'm at the second term, n plus 1 would be the third term. If I'm at the fourth term, n plus 1 would be the fifth term. So to get to my next term, I take my current term, which is just t of n, and if I look at my pattern here, I am multiplying by 3. So those two things together make up the recursive equation. For the second example, what I want to do is look at this explicit equation, and I just want to show you how to write the recursive equation for that. So if I'm looking here, this is t of 0, and then this is that common ratio. So I'm actually, instead of starting with 1, like I did up here, I'm going to start with 0 because that's what the equation gives me. So I will say t of 0 equals 6. And then t of n plus 1 equals. So again, to get to my next term, I take my current term, which is t of n. Now, if I look here, this is the common ratio. So what this means is I'm multiplying by 1/2 every single time. So that means I need to take my current term, and to get to the next term, I need to multiply it by 1/2. And then the last example is just the opposite. So this example, I'm giving the recursive, and I'm going to show you how to write the explicit equation. So to write the explicit equation, I need the zero term, and then I also need the common ratio. All right. So looking here, my recursive equation is saying to get to the next term, you need to take your current term times 4. So in my sequence, I must be repeatedly multiplying by 4. So that's my common ratio. And then let's see, so they give us the first term as 5. Now, if I wanted to get to the next term, I would multiply by 4. However, I want to go back to the 0 term, so I'm going to divide by 4. And again, I'm just going to keep it as a fraction. You could divide it out and give me the decimal answer. It's completely up to you how you want to handle that. So then to write my equation, I would say t of n equals 0 term 5/4 times 4 to the power of n. All right, so this is the explicit equation based off of the information I got from the recursive equation.